Good morning, everyone. Welcome to our senior design project. My name is Jorge, and I'm the builder. We decided to create an IoT control system for our senior design. So the initial objective was to create a way to have any sort of device that we could control remotely, essentially. So the first thing that comes to mind is via an app, but in the initial idea, it wasn't a part of the plan. So basically from scratch, create a system that we can control X, Y, or Z devices. So here is basically what the entire system looks like. If we start from the right and move on towards the left, you see we have two devices, a fan and an LED RGB strip, which is hooked up to the ESP32 microcontroller, which is popular for having both Bluetooth and Wi-Fi capabilities. So it was a pretty easy choice there. All of the data that gets sent to and from the ESP get routed through a central hub, in this case a Raspberry Pi. And this is just in charge of allowing connections between multiple devices under certain topics that are of interest for those devices. Then we move to what is outside of what would be a local network, to the server. And this server is in charge of, again, forwarding data, but instead of from device to hub, it's from a client, in this case a phone, to the hub, which will then forward to the devices and have that back and forth control.
So essentially, to go a little bit more into the hardware, there were various pieces of equipment that we went through in terms of prototyping for the boards. Some were replaced, some were just left, and then some were extras. We tried to mock up a design cost of essentially what the entire overall project itself, including all extras and other components, would come out to. So the project itself is around $150, up to $200 at most, discounting for the software cost. Essentially, we had some pieces of equipment that we'd already owned that we put to use, and there's a lot of pieces of equipment that are left extra over. So the boards themselves are maybe about $20 to $30 in terms of like hardware costs for just a singular PCB board.
Yeah. So the only software cost that we thought about was really the server, because again, it's a recurring cost. You're paying for access to a computer somewhere else. So that's pretty much the only software cost that we do.
So to go a little bit more into the hardware, we got some pictures of various development stages of the hardware, as well as some of the final stages of development. There were various problems that we encountered going through it that we had to come up with solutions for. We wanted to include a hardware button to control some of the inputs for debugging mostly, and we noticed that there were some errors that we had with button bouncing due to voltage bouncing itself. So we implemented some debouncing circuits to handle the voltage bounce in the buttons, as well as we implemented different power systems than what's included here right now to handle the total amperage of our design, which ended up going up over time as we introduced more components to the circuit. So this right here is the final PCB schematic. We have sent these in already to a PCB manufacturer. We're just awaiting the boards to be shipped. But the PCB is a 4-layer PCB that includes a power layer at the top, as well as on one of the circuits, this lower one right here, there is the button debounce circuit, which is the second layer, which is away from the power layers to try to ensure that there's not too much crosstalk between the traces. And then below that, in the second inner layer, there is an entire ground plane, which helps to ground the entire PCB board, as well as prevent any crosstalk between the bottom of the board and the top of the board, which is why the bottom of the board traces I have crossing over some of the other traces. The ground plane should prevent the traces from talking to each other and fooling our data.
So on to the programming of the microcontroller themselves. Since they're ESPs, the main company that creates them is Espresso, and for that, they have created a framework that you're able to go in and use many other libraries to create essentially any IoT application, in this case, our devices. So, yeah, that's the framework, and one of the interesting features of the framework is the inclusion of what is known as free RTOS, which is stands for real-time operating system. Now, this is used for other serious industries as medical or aerospace. Essentially allows you to have multiple processes running given limited constraints. In this case, the ESPs have 2 cores, but as you can see here, we have 4 tasks that are running and allow us to have more functionality. So a simple way to put it is we created one task for just the Wi-Fi, so handling connection and then dropouts and reconnection. And then the other is for the protocol that is used to communicate between ESP and the broker. Yeah, so this is kind of a byproduct of having the broker being the Raspberry Pi, essentially the hub. We wanted a way so that, say you're not physically with the device, you still want to control it, you can access it via a hub. In this case, this is running directly on the Raspberry Pi, and shows a nice GUI interface that just shows you the data of your devices, whether or not they're online, their power status, for the RGB colors, the color, and then etc.
So the GUI itself, we kind of just designed using HTML for the Pi. This is because we don't really need to jump across multiple different types of operating systems. We only have the Pi that's in consideration here. So HTML was our simplest option that we could go with. It's just a various stack of like grid placement as well as images stacked on to allow for an easy interactive system for you to move around the device when you're looking at the hub itself.
So this is the architecture of the server. Basically, we decided to use Golang for similar to free RTOS, where you can create tasks that run in the background concurrently. So for this, we decided to use WebSockets between the broker and the server. This creates a bidirectional persistent connection, meaning the only way that the connection drops is if there's an error or you explicitly tell it to drop. And since it's bidirectional, we can send to and from broker and server. So the code snippet you see here is for the broadcast function, meaning if there's a data that is coming to the server from a client, you want that data to be forwarded to the broker. And vice versa, if it's coming from the broker, you want the client to know that data. So the broker might be sending constant packets of status, while the client is only sending control packets. And then, yeah, this is the app that we decided to create for the client. It's using React Native, so we're able to leverage both iOS and Android devices. And all we have to do here is hook up to the cloud server and have that functionality of you saw previously the dashboard GUI. Basically, anywhere. All you need is an internet connection. You load up the app and connects to our server, which then prompts the update of data. And then each of these is a page that you will go into and have more control over the device. And yeah, so just a recap of the big picture here that we decided to implement. We have, again, the devices themselves. So pretty much you can visualize the data flow that happens back and forth between devices. And I think it was a great learning experience because in real embedded systems, maybe you're not necessarily working with Wi-Fi, but you're working with other protocols that might, and you might have more experience using Wi-Fi and the TCP stack for those applications. And then this is pretty much our last slide. These are information if you guys are interested in maybe learning more on the project. The 2 links above are for the repository of all our code that went through to make this project. And then the second one is an extra feature that is not present here, but basically a way to control your devices using your voice. Something like that.
So we do have an application Let me see.
So now we're going to transition into sort of a live demo. We pretty much have everything required to emulate what you guys see here. In this case, here's the Pi, and you can see kind of a small screen, but nonetheless a screen. So we're going to connect that. And
Yeah, to just the debugging buttons are placed here on these two circuits. Feel free to come up and just, if you want, just cycle through. There's various, there's a power control right here, which is closest to our inverter, and then a color change, as well as there is a similar power control here for the fan, as well as a speed cycle switch.
so if you guys wanted to kind of envision this, I'm using the laptop as a router. So this is providing internet access to the 3 devices, the 2 ESPs, and then the Pi. And then all that's left is to see the Raspberry Pi. So basically now we have created the end-to-end connection between each device. Where's my phone?
Now on the app screen, before the devices were grayed out because they weren't detected, this would be the same if the devices were off. The devices are operable and selectable when they are active.
You want to reload? It work?
No, it works. So if you want, just feel free to cycle through the app. Any kind of changes you want, just clicking on the screen itself will take you further into the control.
You get taken to each device page and you have the live status. So here you see the RPM.
So after every change, you want to hit apply settings, and then that'll allow it to take adjustment.
Yeah, you can click on
This slider's a little bit laggy. If you tap it, it's better than dragging it.
Yeah, so for the fan, we have a special mode called breeze mode. So if you wanted to have the effect of a breeze, all you would do is and we also implemented audio feedback that basically tells you whether or not a mode was activated. Especially for the fan, you don't know, especially if I can pass this around. So this is pretty much the app.
Well, that's a crazy response time.
Here we have the
Yeah, the RTOS really helps it
Yeah, I
to
guess it's
respond very fast.
I already saw it.
The most easiest one to see is the breeze mode. So
I'm gonna put it to work. You know, if I put it to work,
For sure.
Relay clip. So Dylan, can you click on the pen clip to stop the blades?
Yeah, for sure.
Not just cover your hand. Yeah.
damn,
Just to show that.
that's a good
so now
response. That's a good
it's put on.
response.
And then I want to activate breeze mode. I want the breeze effect. It's not that loud, but you heard that voice response. And then say I don't want breeze mode and I just want full speed. I'm gonna set that, apply it, and then you guys can get closer, feel the air, up to you. But yeah, this is pretty much our vision really of what we wanted. So you guys can play with that as well. I mean, if it interacts with the other app, I mean, up to you guys. Yeah, so he has the iOS version, and then this is the Android. You guys can compare if you want. I mean, they're pretty similar. And then we can showcase wherever you guys are. We can showcase what happens when a device goes offline. So can you?
Yeah, here, I'll just remove power from the fan.
So we'll disconnect the fan, and then wherever you guys are at that point, you see, right? So now you can't even interact with it. So you know something's wrong. And then it should be similar here. Exactly.
Yeah.
Yeah, so we wanted that feature as well. We didn't get too advanced. We'd say, I don't even know what they're called. The on-screen messages of, hey, this device is connected. You know, just simple. You see whether or not something's connected, and then, hey, something's wrong. I'm gonna connect it, and then, yeah, that's pretty much our vision.
Let's see if the device.
And then if you guys want to get closer, you guys can see the dashboard GUI. It's relatively small, but for what it is, again, you're able to see everything. And all features of
of the app kind of stem from this. So again, if you disconnect the fan,
Oh, yes.
if you disconnect the fan, after a while, it will detect that, and then not let you even enter the page, right? So it's kind of a fork of this, however you might think of it. But yeah, that's pretty much it. Thank you guys.
You can.
Thank you.
Can you also control from there too?
Yeah. So, is it back? So it's off right now.
Oh wow, that's cool.
Go here, turn on breeze mode. Yeah, it's just when
Good
what
too.
you saw the big picture. It just facilitates that way. Yeah.
The same information that travels to the apps is the same information that travels to this control system. So that,
It was easy to integrate.
yeah, it's just two different GUIs essentially running the same info group.
Thank you.
Yeah. Thank you guys.